Okay, in this video we're going to talk about expected value and expected value calculations. Actually, probably some of you are being affected by expected value calculations right now. If you have an auto insurance policy, then that premium is calculated based on the probability that you will cost the insurance company money versus the payout and all these other things. So they use a calculation very similar to this to calculate what your premium should be. The higher your probability of costing the company, the more your premium is going to be. The lower your probability of costing the company money, the lower, the cheaper they can make your premium. That's always a good thing. So comes up there, comes up in business decisions, and it comes up in game theory. It's a way of evaluating outcomes of a game to determine if a game is actually fair or not. Game theory is actually a whole branch of mathematics on its own, and it can be fairly complicated and uses a lot of probabilities. So let's take an example. We're going to play a game, and the way this game works is you come to the table and you get to roll a six-sided die. Okay? And depending on the outcome of that roll, one of three things happen. First of all, you have to pay $1 to play the game. You pay $1 to play the game. Each time you roll the dice, you have to pay $1. But if you get a 1, 2, or 3, nothing happens. There's no payout. You simply lose your $1. Okay? So if you roll a 1, 2, or 3, you lose $1. Okay? The probability of rolling a 1, 2, or 3, since there's 6 outcomes and 3 that we're looking at here, is 3 out of 6, right? So we'll just make a note of that. That's 3 out of 6, or 1 and 2. You got a 50-cent chance of just simply losing your $1. If you roll a 4 or 6, however, you get $2 back, right? Well, the probability of rolling a 4 or 5 is 2 out of 6. Or 1 in 3. Excellent. And then finally, if you roll a 6, you get $8. That would be nice. Okay, so if you pay $1 and you get $8, then super. So here you go. The probability of rolling a 6, though, is only 1 in 6. And that can't be simplified. So how do we find the expected value? Well, what we do is we take the probability for each of these events, right? So our expected value is equal to the outcome, right, the gain or loss, times the probability of that happening. So what's the probability of simply losing $1? Well, the probability of simply losing $1 is 1 in 2. So we're going to take -1, and we're going to multiply it by 1/2. That's the probability that that's going to happen. Then we're going to add to it this outcome. This is actually, we're going to win $2, and the probability of that happening is 1 in 3. Okay, so we're taking the outcomes times the probability that that outcome is happening, and then we're simply adding them all together. Finally, we could win $8. And the probability of that happening is 1 in 6. Now the question that you might want to ask before you ever go up and pay $1 to play this game, you might want to ask yourself, is this a good game, right? What are my chances in the long run? Let's say I play the game 10 times. Am I just going to lose a bunch of money? Or do I stand to maybe come out ahead? Well, obviously, if I'm lucky enough to roll a bunch of 6s, I can come out ahead. So there's certainly a way to do it, but what would we really expect in the long run if we played the game? Expected value is a way of calculating exactly that. So basically we can do each of these calculations, and we'll just do that, and we'll add them up. And this is -1/2 plus 2/3 plus 8/6. And probably should have just left my fractions unsimplified. I would have made this a little easier. So now I'm going to put these all as a common denominator. So negative 1/2 is really negative 3 over 6, okay? And then this is 4 over 6. And this is still 8 over 6. And let's see, that's 12 minus 3. That's going to be 9 over 6, right? Which is 1.5, or the way to think of this is we can expect that our payback is $1.50. Now that's more than the dollar you're spending, which means that in the long run, you should come out ahead playing this game. If you played this game 20 times, you should walk away from the table with more money than you had to pay to play the game. Now, notice that in any particular game, there's no way for you to come out ahead by $1.50, right? There's no way for you to walk away and say, oh, I played it once, made $1.50. That won't happen, and that's not what this is telling you. It's just telling you that over the long run, repeated play should get you back $1.50. So if you paid to play the game 100 times, paid in $100, you should walk away from the table. You should walk away from the table with about $150, maybe. But that's what an expectation would be based on the probabilities, and that's what expected value is all about. So to calculate an expected value in general, look at each outcome, multiply the gain-loss times the probability of that outcome, add them together, and you've got your expected value.